So question 18. So it says, on Saturday some adults and some children were in the theatre. I'm gonna start highlighting things. There's a lot of stuff here to be read. The ratio of the number of adults to children was 5:2, and each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had a seat in the stalls, and then 117 children had a seat in the circles, and there's exactly 2,600 seats in the theatre. So on this Saturday, were there people on more than 70% of the seats? So I guess that's the exam question, if you like. So were there more than 60% of the seats? Alright, so let's figure that out. So we know that 5 plus 2 gives us 7. So there's 7 parts to this. 5 and 2 from the ratio. So that means 5/7 parts were adults. And then 2/7 were children. And then we know that 3/4 of the children had seats in the stalls. So 3/4 in stalls. That means that 1/4 were in circle, and it says that if we multiply, so 2/7 times 114, we get 2/28, which simplifies as 1/14. So 1/14 children in circle. And then we know that 114 equals 117 children in the circle. So it's given, that number is given to us. So that should be equal to 117. Right? So that means that if we want to find out the total number of children, total number of people, then it's going to be 117 times by 14, which gives 1,638. So come back here, 1,638. We know there's 2,600 seats, and times by 100, so that gives us 63%. So that means that yes, more than 60% of seats had people on them. Brilliant. Okay, question 19 says the diagram shows prism with a cross section in the shape of a trapezium. So on the centimeter grid below, draw the front elevation and the side elevation of the prism. Use a scale of 2 centimeters to 1 meter. Right, so basically it's saying that each one is 1 meter. So if you use 2 centimeters, that's 1 meter. So 1 centimeter, 2 centimeter, which will give you 1 meter. So essentially each one is 0.5 meters. Okay, so let's draw. So this is the front. It's telling this is the front face, and then this is the side face, or view, however you want to put it. So if we want to draw the front first, so let's draw the front first. So we know that the front facing side, this is going to be 2 meters. And if each one is 0.5, that means we're going to have 4. So 1, 2, 3, 4. and then the same thing, so 1, 2, 3, 4, and then we've got 0.5, so it's going to be that. Connect that up, brilliant. And then if we have the side, so same thing, so this is 1 meter, so that's 2 boxes, and then it goes up. If you're looking at it from the side, it goes up by 2 meters, so that's that. Same thing. Oh, let me just rub that off. I know it's not straight, but that's just nowhere near good enough, so I'll do that. Connect that. So essentially it's meant to be crossing the edges straight, and then you can see we have this line here at 0.5, so that needs to also come across there. So again, obviously I can't draw straight lines, but as long as I tell you that these lines should be straight and they should be going, you're tracing across the borders. Okay, question 20. So there's quite a bit of information here. Let's summarize it. So Ollie drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. His average speed from Liverpool to Manchester was 70 kilometers per hour. And then Ollie took 75 minutes to drive from Manchester to Sheffield. So work out his average speed for his total drive from Liverpool to Sheffield. Let's just highlight some stuff here, just so we know what we're dealing with. So that's the first part, Liverpool to Manchester. And then this is Liverpool to Manchester. And then I'm going to highlight this and highlight that. So all the relevant stuff I want to highlight with one another. And then essentially it wants from Liverpool to Sheffield. And it's broken up from Liverpool to Manchester, then Manchester, Sheffield, so into 2 parts. So remember we had the distance, speed, and time, so that triangle. Right. So let's do L to M. I'm just going to use the initials. So the time it took him, so time was 56 over 70, so 4 over 5 equals 48 minutes, because we have 4 over 5 times by 60, which equals 48. And then so M to S, probably use a different color here. So M to S, so it took him 75 minutes, and so the total distance was 56 plus 61, and then that's 117 kilometers. And then the total time, so I'll do that. So total time was 123 minutes, which is, you can change that to 2.05 hours. So the average speed, so average speed was 117 divided by 2.05, which is 57.07, and so forth. So if we round to two significant figures, we get 57 kilometers per hour. So just to recap, essentially what we've done is we know that it travels 56 kilometers. And the average speed from Liverpool to Manchester was 70 kilometers, which is 4 over 5. And we know that 4 over 5 times by 60, because we're dealing in hours here, so 1 hour 60 minutes, gives 48 minutes. That's how we got that. So we probably should do this. And then so the total distance was 56 plus 61. 117, and then total time was 48 plus 75. So we convert that into hours, 2.05 hours, because we want our answer in hours. So 117, so kilometers, divided, that forward slash is divided sign by hours, so 2.05, which gives us 57.07 and so forth. So two significant figures, 57 kilometers per hour. So the next part is Jamie drove from Barnsley to York. Oh, Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 miles an hour. Her average speed from Leeds to York was 60 kilometers per hour. And then Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers an hour and 60 kilometers per hour. So if Janie is correct, what does this tell you about the two parts of Janie's journey? So that means that, if she's correct, that means that the time must be the same. Okay. So question 21. So again, we have one of these shape questions. So A, B, C, and E, D, C are straight lines. E, A, and D, B are parallel, and you can tell because of these arrowheads pointing in the same direction. And then you also said EC equals 8.1, so that whole thing is 8.1. I'm just going to put that there, centimeters. DC is equals 5.4, and it says DB is 2.6. So it says work out AE. So what is AE? So I'm going to put a X there. Right, so what we can use here is scale factor. So we can say, scale. So we can say that since the whole thing from E to C is 8.1, and this D to C is 5.4, scale factor of 1.5. So this line is 2.6, times it by 1.5, you're going to get 3.9. So the answer is 3.9 centimeters. So X will be 3.9. Okay, and again, it's just to do with scale factor. Just drawing out these lines to make it look a little bit more clear. Okay, so the next part is AC equals 6.115. Use a different color here. So AC 6.15, so 6.15. Okay, work out the length of AB. So again, very similar. So just scrolling down ever so slightly. So BC, which is here, is going to equal 6.15 divided by 1.5. So that gives us 4.1. So AB equals 6.15, take away 4.1. So AB is that part, and BC is that. So BC, so 4.1. So that's going to give us 2.05. Question 22. So Anil wants to invest 25,000 for 3 years in a bank. He's got his personal bank and secure bank. Compound interest, so 2% for each year, and compound interest 4.3% for the first year and 0.9 for each extra year. So which bank will give Anil the most interest at the end of year 3? So I'm just going to highlight some stuff for myself. So I think it's important. So 3 years, so 2%, it's 4%, 0.9 for the following year after that. So what we're going to do is use the compound interest formula. So we take 25,000, multiply it by 1.02 to the power of 3. Remember, so the initial figure is 25,000, excuse that, and we have over 3 years, so that's the initial, times by 1.02, so 2% is 0.2, and then we want 3 years, so to the power of 3. Okay, so that will give us, if you put it in a calculator, so you'll get 26,530 and 20 pence. And then, so that's for personal bank. I'll use a different color for secure. So secure bank. So the same logic. So 25,000 times by, so first you can do 1.043, because remember here's 4.3% for the first year. Then you're going to multiply by 1.009, so which is 0.9%, refers to that, to the power of 2 for each extra year. And because it's a total of 3 years, so 1 year refers to this, and then the subsequent 2 years refers to that. So you will get 26,546 pounds and 46 pence. So which one gives you more? Essentially secure bank. Okay. Question 23. So a number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval for n. So basically, if you draw a straight line and it says the result is 4.76, so that's 4.77, and it's going to have 4.75. So where you would round it up, use a different, is 4.755, and you would round it down from, or rather 4.765, so it would be rounded up to this from that point. So you say 4.755 is less than or equal to n, which is greater than 4.765. Although you could also say 4.755 n is less than or equal to 4.764. And I mean, if you wanted to play around with the inequalities, so you'll get different things. And then question 24. So we've got this quadratic here, x squared plus 5x minus 24 equals 0. So essentially you want x that satisfies the rule. So that satisfies the quadratic. So we could use the product sum method here. Product sum method. So I can look at this instinctively and I can say that my x, which is going to follow this rule, could be minus 3 and 8. So let's put them into this factorized form in brackets. So x plus 8x minus 3 equals 0. So that implies that x equals minus 8 and x equals 3. And the final question, 25. So here are the first 6 terms of an arithmetic sequence: 3, 8, 13, 18, 23, and 28. So find an expression in terms of n for the nth term of the sequence. So the best thing to do is to take the differences. So 5, 5, 5, and you know they're all going to be 5 because arithmetic. So it's going to be 5n. And then, well, we're going to subtract 5 from that. Subtract by 5, which gives us minus 2. So if we go back 5, we get minus 2. So minus 2. So our total answer will just be 5n minus 2. So that's the expression. And then it says the nth term of a different sequence is 3n squared. Nathan says the fourth term of the sequence is 144. Is Nathan right? Show how you get your answer. So 3n squared. He says the fourth term. So that means n equals 4 in this case. So 4 squared, which is 3 times 16, which would give us 48. So unfortunately, so no, Nathan is wrong. And that's the end of this paper.